In this lesson, we're going to look at observational studies versus designed experiments. So in an observational study, we measure characteristics of a population just by studying individual samples. We don't attempt to modify, manipulate, or influence the variables being studied. For example, when we poll somebody, just ask them questions. We don't attempt to separate into groups and do one group one way, one group another way. We just kind of see what's happening. Design experiment, we do apply some sort of treatment to the individuals, call them subjects, and then we attempt to isolate the effects of that treatment to see if that treatment actually has an effect, right? For example, clinical trials of a drug, group 1 gets the drug, group 2 gets the placebo. Classic case of a designed experiment, right? We also do things like double blind, where the people do not know if they're getting the subjects themselves do not know if they're getting the real drug with the placebo, and even the experimenters themselves do not know which one. It's just to make sure that nobody is influenced by knowing that. There are some disadvantages, and we will talk about a few of these effects later on in the course, called the Hawthorne effect, the placebo effect, Pygmalion effect, confounding variables, and certainly some ethical concerns. So the Hawthorne effect, this occurred when an experiment was done in a factory called Hawthorne Works. The subjects being studied temporarily changed their behavior because they knew they were being studied and part of an experiment. The placebo effect is sort of a fake treatment that looks like the real treatment. Some drug manufacturers actually have engineered placebos that have the same side effects as the drug being tested. So with our drug example, some people will experience improvements even when they were given nothing other than a sugar pill, and this is called the placebo effect. Something else called the Pygmalion effect. This is a pretty famous experiment where students actually perform better based on teacher expectation. The purpose of the experiment was actually to support the hypothesis that reality can be influenced by the expectation of others, right? In the experiment, a guy named Rosenthal predicted that when given information that certain students are brighter than others, elementary school teachers may unconsciously behave in ways that actually facilitate and encourage student success. So effects of smoking on lung capacity in women. So a designed experiment may look like this. So let's focus on the design experiment. You find 100 women age 20 who do not currently smoke. You randomly assign 50 of the 100 women to the smoking treatment and the other 50 to no smoking treatment. And those in the smoking group smoke a pack a day for 10 years, while those in the control group remain smoke-free for 10 years. And then measure lung capacity for each of the 100 women, and then analyze and interpret and draw conclusions from the data. Do you see any problems with doing something like that? There are certainly some ethical considerations there, right? Observational study. So let's look over here now. You find 100 women age 30, of which 50 have been smoking a pack a day for 10 years, while the other 50 have been smoke-free for 10 years. So here we're just observing what they've actually been doing. And then you measure lung capacity of each woman and analyze it, interpret, and draw conclusions. No real ethical concerns here on the observational, but we can't say for certain that one of them causes the other, right? Because the women who had been smoking may have had other issues that may have caused some of the things we're looking at. And we'll look at these throughout the course. So the observational study measures the value of the response variable without attempting to influence the value of either the response or the explanatory variables. So in an observational study, the researcher observes the behavior of the individuals in the study without trying to influence the outcome of the study. Okay? The design experiment, if a researcher assigns the individuals in a study to a certain group and then intentionally changes the value of the explanatory variable, whether it be a drug or a placebo or something like that, records the values of how they respond to that variable for each group. The researcher is conducting a designed experiment, and there are different levels of design experiment we'll look at. When you look at confounding and lurking variables real quick, confounding in a study occurs when the effects of two or more explanatory variables are not separated. So any relation that may exist between the explanatory variable and the response variable. They may be due to something else, to another variable, or other variables not even accounted for in the study. Okay, and the concern with all observational studies is the possibility of these confounding variables. A lurking variable is an explanatory variable that was not considered in a study, but that actually affects the value of the response variable in the study. Additionally, lurking variables are typically related to any explanatory variables considered in the study. So just to give you some specific examples here, picture this. So for the following statements, identify which is being considered the explanatory and the response. Hopefully in early lessons we got that figured out. Let's suggest a potential confounding variable that explains the observed association between these two. So here's the first one. Children with larger feet tend to have higher reading scores than children with smaller feet. So what is the confounding variable here? Age, right? Children who are older typically have larger feet. So it's not the fact that the feet are larger that gives them higher grading scores. It's the fact that they're older. That typically older children read better than younger children. Here's another one. Days with a higher number of ice cream sales also tend to have more drownings. So why do you think that's the case? Well, ice cream sales typically are sold higher in the summer, right? People swim more in the summer. So that's the confounding variable, the fact that ice cream sales are actually sold when more people are swimming. So the caution here is we can't make a cause and effect, that we need to stop the sales of ice cream and that'll limit drownings. No, because there's another variable that we maybe not have considered. Here's another one. People who eat apples regularly tend to have fewer cavities. So the question is, can we make the assumption that the association that eating apples causes people to have fewer cavities? No. I mean, people who eat apples probably are healthier eaters to begin with. And so that's the confounding variable. That's not just the fact of eating apples. It's the fact that the people who eat apples tend to have a healthier lifestyle anyway. And so this would be an observational study. Now, if you separated people into groups and you had one group eat lots of apples, the next group didn't, and you controlled for other variables, then you can start making some causality. But until then, we can't. So observational studies do not allow researchers to claim causation. And we'll talk about this quite a bit in this course. So observational studies versus experiments. So observational study may reveal correlation between two variables, but only a randomized experiment can prove cause and effect. Why? Well, this is because confounding may be present in observational studies, as we just talked about. Random assignment, when we randomly assign to treatment and control groups. So picture a bunch of students here. Here are my little students, these little dots are the students. And I randomly put one half in the experimental group and one half in the control group by random assignment. That helps sort of equalize the groups, and it sort of helps remove some of those confounding variables. So any difference in response we can actually attribute to the explanatory variable, whatever that happens to be. This will actually make a little more sense when we actually start applying that to specific situations. A census is a list of all the individuals in a population, along with certain characteristics of each individual, right? Like the cost of the 2000 census was about $6 billion. And because the cost is so high, most researchers obtain data through existing sources, survey samples, or design experiments. Existing sources, so if a data already exists from a prior survey, this could be used, right? We don't want to collect data that has already been collected. Now, the survey sampling and design experiments, the third and fourth one, are what we're going to be doing. So, example here. Determine whether the study depicts an observational study or an experiment. Also state the explanatory and response variables. Okay, so a study to determine whether there is a relation between the rate of cancer and an individual's proximity to tension wires. So pause the video here and see if you can, I didn't give you a whole lot here, so just based on this, what do you think this type of study is, observational or experiment? Okay, welcome back. This is an observational study, right? I think I have that here, yeah. Because it's not, I mean, what would make this an experiment? That could be certainly a good follow-up question, right? Experiment would be you take a random group of people and you assign one group to live near high tension wires and the other group to not live near high tension wires, and then measure the cancer rate. And by the way, the response variable here is the rate of cancer. So that's the response variable. And the explanatory variable is the proximity to high tension wires. Okay. Next one. Rats with cancer are divided into two groups. One group receives 5 milligrams of a drug that is thought to fight cancer, and the other group receives 10 milligrams of that same drug. And after 2 years, the spread of cancer is measured. There should be a period there. So again, pause the video here, see if you can determine if this is an observational study or an experiment, and also state the explanatory and response variables. Okay, welcome back. So hopefully this was an easy one. This is definitely a designed experiment. We're dividing into two groups. We're assuming a random assignment here. And again, our response variable is the spread of cancer. So there's my response variable. Just put an R there. And the explanatory variable is the amount of drug, right? So the explanatory variable is the amount of the drug. Another example, to just determine whether the following study depicts an observational study or an experiment. I'll read it through and then I'll pause it and see if you can figure it out. Researchers want to assess the long-term psychological effects on children evacuated during World War II. They obtained a sample of 169 former evacuees and a control group of 43 people who were children during the war but were not evacuated. The subjects' mental states were evaluated using questionnaires, and it was determined that the psychological well-being of the individuals was adversely affected by evacuation. And I gave you the source there. So see if you can determine whether this was an observational study or design experiment. Okay, welcome back. So this is an observational study, right? We did not assign people to be evacuated and assign one group to not be evacuated. We were just observing what actually already happened, right? And we did have two groups here, so maybe that may have confused you, but we did not impose the explanatory variable on these subjects. And that's what really the question you're asking. Did the researchers impose that explanatory variable? If we did, we want to think design experiment. If we're just observing what has already happened, observational study. We'll look at a couple more. Xylitol has proven effective in preventing dental cavities when included in food or gum. A total of 75 Peruvian children were given milk without xylitol and were asked with and without xylitol and were asked to evaluate the taste of each. Overall, the children prefer the milk flavored with xylitol. And I'll give you the source there. Okay, go ahead and pause the video here. Okay, welcome back. So hopefully you're getting better at these. This was a design experiment, right? We separated the children in two groups and we imposed the explanatory variable, that being if it was flavored with xylitol or not, and then we looked at the response of these. So we had two groups, one with and then one without. Okay, part C. A total of 974 homeless women in the Los Angeles area were surveyed to determine their level of satisfaction with the health care provided by shelter clinics versus health care provided by government clinics. The women reported greater quality satisfaction with the shelter outreach clinics compared to the government clinics. Okay, pause the video here and see if we can get this one. At least mentally go through that. All right, welcome back. What do you think? Observational study, right? Because we are just observing what's happening. We are not imposing the explanatory variable on these homeless women, right? We just sort of look to see which ones they went to, right? They reported a greater quality of satisfaction with the shelter outreach clinics compared with government clinics. We just look to see which one they went to. So they had government, or we'll call outreach. And some women went to government, some women went to the outreach ones. And we just looked. We didn't tell them which ones to go where. And again, we cannot say causality. We cannot say that one is necessarily better than the other. We can just kind of observe what happens, right? Greater association. We can't use really hard language with that. We can't say one causes the other. Greater satisfaction is caused by going to outreach clinics.